All right, settle down. What we're going to do today is we're going to do some solution stoichiometry. Just like with stoichiometry, we are going to start with a balanced equation. So first thing you need is a balanced equation. After that, it's a lot like regular stoichiometry, and in some ways it's actually easier once you get started. A couple of guidelines I want to throw out there. Start, or yeah, let's do this. Just like I've been saying, is use a volume for your given. Preferably one that you can convert. In other words, one that you have a concentration for. One you can convert with a known concentration. Keep in mind, known concentration, moles per liter. Third thing is, like I've been saying, is your concentrations are conversion factors. In other words, they're going to go in the middle of the problem. They are not going to be your given. Essentially, three things you could be solving for. Could be asked to solve for molar mass, which that's what we did in the lab. So you already have a sample calc for that. All right, I'm not going to go through one of those because I went through one of those yesterday. You could be asked to solve for a concentration or an unknown concentration. Keep in mind that would be in moles per liter. Or you could be asked to solve for a volume. Volume of reactant or product. I take that back, it's usually a reactant. All right, like I said, I'm not going to go through this. Did this already, the molar mass one. So let's go ahead and take a look at a couple of examples with unknown concentration and volume of a reactant. You guys ready? Hopefully you've been writing. I'll give you another 30 seconds or so to wrap this up. Especially 6th hour, because I know you guys probably spent the first 2 minutes talking while I was writing this down. Oh, come on, don't be offended. You know you were talking. Hey, if I'm wrong, tell me I'm wrong tomorrow. I'd be more than happy to be wrong. All right. You should have this in front of you. I don't know which problem it is. I'm doing these out of order because I think this order makes a little more sense. So you have this written down already, a 25 milliliter sample of hydrofluoric acid with a concentration of 0.275 molar, requires 12.1 milliliters of calcium hydroxide to neutralize it. What is the concentration of the calcium hydroxide? So, you know what, I want to move this up a bit. Give me a little more room. So we've already done a titration. Here's what's happening. We've got a burette, got some sort of beaker underneath it. I'm not going to draw a flask. Sample of hydrofluoric acid requires 12.1 milliliters of calcium hydroxide. So the calcium hydroxide is in here, and the hydrofluoric acid is in here. And we're going to drip, we're going to drip our base, our calcium hydroxide, into the hydrofluoric acid. Some sort of indicator tells us when the reaction's over, just like with our lab. And we titrated 12.1 milliliters. Well, we said for stoichiometry, first thing we need is a balanced equation. So let's go ahead and get a balanced equation. All these neutralization reactions are basically an acid reacting with a base. They're just a specific kind of double replacement reaction. So let's go ahead and write this out, and you'll see how this works. We're going to have calcium hydroxide reacting with hydrofluoric acid to produce, well, if it's a double replacement reaction, that means the calcium and the fluorine are going to get together. That's a calcium with a +2, fluorine with a -1, so that's going to be CaF2. And then I've got hydrogen getting together with hydroxide, HOH, which we talked about yesterday, is going to be H2O. Just need to balance it now. Balancing, let's see here, I've got 2, 3 hydrogens. Let's start here. This is a better place to start. I got 2 fluorines here, 1 fluorine here, so let's put a 2 there. That means I got 2 plus another 2 is 4 hydrogens. So I put a 2 there. That gives me 4 hydrogens over here and 2 oxygens to balance the 2 oxygens there. My reaction is balanced. So I said that we would start with a volume as our given, preferably a volume that I can convert using a concentration. Well, I've got 25 milliliters of hydrofluoric acid, and we know the concentration of that. That's the one I can convert. 12.1 milliliters of calcium hydroxide, I don't have anything to convert that with. I can't convert that to moles. I've got no concentration to go with it. So what I'm going to do is I'm going to start with that 25 milliliters, 25.0 milliliters. That's milliliters. You know what? I'm not even going to put in the conversion. We already know that we're going to divide this by 1,000. So let's just go ahead and do this. Dividing that by 1,000 to get to liters, we're going to have 0.02500. I need those last 2 zeros because of sig figs. I have 4 sig figs here. I need 4 sig figs here. Liters. And that's liters of hydrofluoric acid. Okay, well, now I can go ahead and convert that to moles of hydrofluoric acid by saying that there are 0.275 moles of hydrofluoric acid. Where did that come from? Well, that's my concentration right there over 1 liter of solution. That cancels, that cancels. So I've got moles of hydrofluoric. Oh, you know what? I didn't even talk about what I was looking for. I'm looking for concentration of calcium hydroxide. So that means I need moles per liter for my calcium hydroxide. Well, I know how many liters I used. It's right here, right? Well, I don't have it directly, but I know if I divide that by 1,000, I'm going to have my liters. So it's kind of similar to what we were doing with the lab. I know on the bottom is going to be 0.0121 liters of this stuff. I need to figure out my moles to put in there to get my final concentration. That's what I'm working on here. I'm going from liters to moles of hydrofluoric acid. Well, now from moles of hydrofluoric acid, I'm going to go to moles of calcium hydroxide. Well, where am I going to get info on that? I'm going back to the balanced equation, and I'm looking at this and this to get my molar ratio. So for every 2 moles of hydrofluoric acid, which goes on the bottom so I can cancel it, I get 1 mole calcium hydroxide. My moles of calcium hydroxide cancel, or excuse me, my moles of hydrofluoric acid cancel. I'm left with moles of calcium hydroxide, which is going to go down here. Right? We said that's what we were looking for. Yeah. So let's go ahead and calculate this. I'm going to grab a calculator. I'm going to go 0.025 times 0.275 divided by 2. Yeah, I'm not going to do that in my head. Forget it. So I've got, when I say 0.025 times 0.275, hit enter, divided by 2, hit enter. I got point, again, I need 3 sig figs, because there's, right there, 3 sig figs. Least amount in the problem, so I need 0.00, it'll be 344. 0.00344. Let me double check that. 00344. Yeah. Put that in here. That goes right in there. 0.00344 divided by 0.012. So all I'm going to do is I'm going to take this, my answer, and divide that by 0.0121. Hit enter, and I get a concentration of 3 sig figs, 0.284 moles per liter. 0.284 moles. Oh! Oh, let's move that over. Let's just do this. 0.284 moles per liter. Big M stands for moles per liter, right? Molar. There we go. Again, I was looking for moles. Stick in here and get moles per liter, because I already knew my liters. Well, indirectly, I knew my milliliters and could convert it. Started with a balanced equation. So let's take a look at my guidelines. I started with a balanced equation. I used a volume for my given, and I solved for the unknown concentration. There. I've got calcium hydroxide in there. All right, so that's one type of problem. Another type of problem is finding volume. So let's go down here. Again, you've got this written down in front of you already. Find it. What is the volume of 0.32 molar sodium hydroxide? Excuse me. What volume of 0.32 molar sodium hydroxide is needed to neutralize 50 milliliters of 25 molar, excuse me, 0.25 molar hydrochloric acid? So again, what I've got is one of the two things. It doesn't really matter in this case. I've got the hydrochloric acid here, and I'm running some sodium hydroxide into it through burette, perhaps. And I get some sort of neutralization reaction, which again is just a specific, special kind of double replacement reaction. So I've got sodium hydroxide plus hydrochloric acid. It's going to produce, well, the positive gets together with the negative, so that's NaCl, because it's a positive 1, negative 1, and then HOH, which is just H2O, water. It's already balanced, right? 1 sodium, 1 sodium, 1 oxygen, 1 oxygen, 2 hydrogens there, 2 hydrogens there, 1 chlorine, 1 chlorine. So it's already balanced. I am looking for a volume. So what I'm going to do is I'm going to start with a volume that I can convert. So here's a volume that I've got, and I can convert it because I know the concentration. So that's what I'm going to start with. So let's do this. Again, I'm going liters because this is milliliters, but this is moles per liter over here. Concentration is in moles per liter. So I'm going to go with 0.0500, keep my sig figs, liters times 0.25 moles hydrochloric acid over 1 liter. These guys cancel out. So now I need to go from moles of hydrochloric acid to moles of sodium hydroxide. So I'm looking at this and this for my molar ratio. Well, it's a 1-to-1 ratio. So it's 1 mole sodium hydroxide over 1 mole hydrochloric acid. Again, these guys cancel. I've got moles of moles of sodium hydroxide. I need to get to a volume of sodium hydroxide. I'm going to use this concentration here as a conversion factor. Remember, this is moles per liter. So what I can do is I can say that, I can say that for every 0.32 moles sodium hydroxide, I have 1 liter of solution. So then these guys cancel, and I'm left with liters. Now I could leave it in liters because it doesn't really say whether I need milliliters or liters, but you know what, I'm just going to give both. All right, so let's go ahead and calculate this out. So I'm going to have my 0.05 times 0.25, hit enter, and then I'm going to divide that by 0.32, hit enter. Whoops, what the heck happened there? Let's do this again. 0.05 times 0.25, hit enter. Now divide that by, there we go, 0.32, hit enter. So I get 0.039 2 sig figs, because that's all I got, most 2 sig figs in there. So I get 0.039, 0.039 liters, which is the same as, multiply that by 1,000, 39 milliliters sodium hydroxide. Boom, done. All right, keep in mind, if this wasn't a 1-to-1 ratio, this would be different. This part would be different. But fortunately, we have a 1-to-1 ratio based on this, so it really doesn't change anything. Like this last one, we had a 2-to-1 ratio, or a 1-to-2 ratio. I'm going to do one more example, and then I'm going to turn you guys loose on the homework, which is 19-3 practice problems, which is all titration problems. Stoichiometry. Here's the last one that I'm going to do, looking for the volume of, and again, you have this written down in front of you somewhere, volume of 0.75 molar nitric acid needed to neutralize 45 milliliters of 0.50 molar barium hydroxide. So what's going on here is I've got some barium hydroxide, BaOH2, and I'm running some nitric acid into it, HNO3, nitric acid. So I need a reaction for this, and that reaction is, again, it's a neutralization reaction, just an acid and a base reacting, which is a special double replacement. I've got barium hydroxide reacting with nitric acid to produce, it's always going to be water because I'm always going to have HOH, it's just a matter of how much water. So H2O and BaNO3, this is a positive 2, that's a negative 1, so it's going to be BaNO3 twice. balancing this up, let's see here. What would be easy? I've got 2 nitrogens here. I've got 1 nitrogen here, so let's put a 2 there. That gives me, let's see here. That gives me 4 hydrogens there. I've only got 2 hydrogens there, so let's put a 2 there, and I think that'll do it. 1 barium, 1 barium. 2 plus another 6 is 8 oxygens. 2 plus another 6 is 8 oxygens. 2 hydrogens plus another 2 is 4 hydrogens. Yeah, we're good. We're there. 2 nitrogens over there. Yep, we're all good. So again, I'm starting with a volume that I can convert. Oh, I'm looking for a volume. Yeah, so I'm going to start with a volume that I can convert. So I'm starting with 0.045 liters. Oops, that needs another 0 for sig figs. Right there, sig fig. Liters times, I'm going to use 0.50 moles barium hydroxide, BaOH2, over 1 liter. My liters are going to cancel. I'll cancel it out later. I need to get to nitric acid, moles of nitric acid. So I'm going to use the equation to get my molar ratio. Stoichiometry, remember? So I got 2 moles nitric acid over 1 mole barium hydroxide. Where the heck did I get the 2 and the 1 from? Come on, everybody. Molar ratio, balanced equation. Right there. There's a 1 there. There's a 2 there. All right. 2, 1. We're there. So then, oops. All right, I got to get rid of moles and get to liters, get rid of moles of nitric acid. So there's my concentration. So the 0.75 moles nitric acid goes on the bottom. Remember, big M is moles per liter. Moles per liter. So that means 1 liter on the top. Now let's go ahead and cancel some stuff up here. Liters cancels liters. Moles of barium hydroxide, moles of barium hydroxide, moles of nitric acid, moles of nitric acid. I'm left with liters of nitric acid. Why? Because it's tied to that. So let's go ahead and calculate it up, and then we can just go ahead and put it into milliliters too. Again, it really doesn't say what to put it in, so I'm going to do both. So I got 0.045 times 0.5 times 2, hit enter, and then I got 0.75 on the bottom, so I'm going to divide by 0.75. Hopefully you guys are following along with your calculators and coming up with the same numbers. So I get 0.06 liters, which is the same as 60. I need a 0 on there because it's sig figs. Decimal point, milliliters, HNO3, boom, done. All right, so you should have an example of each one of these types of problems. Again, you've got one from yesterday for the lab. That's for finding molar mass. You've got one for unknown concentration. That's this first one that I did right here. And then you've got 2 for finding the volume of a reactant. Yeah, that one and that one. There is a 4th problem, but you know what? I'm afraid I'm going to run out of time here. I want you guys to go ahead and maybe do that on your own if you feel like it. I've been talking for 25 minutes, plenty. So you guys work on 19-3 practice problems. Take it easy. See y'all Thursday. Bye.